Hey guys, and welcome to the school station. Today's video I'm going to be teaching you guys power and Sankey diagrams. This is from the AQA GCSE Physics 9-1 from the unit Energy and Energy Resources. Today we're going to be looking at power and also Sankey diagrams, so this video will be split up into two parts. So the first part of this video is going to be talking about power. Now power is about how powerful an object is, and there is actually a formula to calculate power. The formula to calculate power is actually power is equals to energy change divided by time, or you can just remember it as P is equals to E divided by T. So this is a formula that you will need to use when you're actually in your exam and you're calculating power. And there's a triangle over here. So for example, if you want to try to find power, you would cover this side and you would do E divided by T, which is the regular formula. But sometimes if they ask you to actually find the energy change and you have the power and time, then you have to cover this up, so you will have to do power times time. So this triangle is really helpful to remember because you can basically just cover up the thing that you're trying to find, and you can see whether you have to divide or multiply the things that you have already. So this is a formula that you'll have to remember. So pause this video and maybe try to write it down somewhere or try to memorize it before continuing with the rest of the video. Alright, so now that you have actually know the formula of power, now we're actually going to be looking at an energy and power question. Okay, so this is maybe a typical exam question that might come up in your exam. So it's telling you that an electric motor transfers 10,000 joules of energy in 25 seconds. Work out its power. So since we now know the formula, I want you to pause this video and try this question yourself, and then we will see how to actually work it out. Alright guys, so I hope you guys have tried it out, and here is the answer. We have P is equals to E divided by T, and then because the energy change is 10,000 joules and the time is 25 seconds, so 10,000 divided by 25 is 400, and power is, the unit for power is actually watts, so the answer is 400 watts. So now we're going to be going on to the second part of the video, which is actually going to be talking to you guys about what is a Sankey diagram. So a Sankey diagram is a graphical representation of showing how efficient an object is. So if you guys have seen my last video about energy, you guys have known that energy transfers and energy cannot be created or destroyed. For example, if you have a light bulb and you put in electrical energy, it will always come out as, let's say, heat energy and light energy. So there's always going to be a dissipated energy, and there's going to be a useful energy. However, during the exams, we actually have to know how to present this. Therefore, a Sankey diagram actually helps us, because a Sankey diagram is a graphical representation of showing how efficient an object is. So sometimes they actually may tell you in the exam to actually use efficiency formula to actually work out how efficient the object is, and then you'll have to represent it graphically, and you'll have to represent it using a Sankey diagram. So this is what a Sankey diagram is. So over here we have 200,000 joules of energy in the gas, and basically we're putting in this much energy, and then we have 12,000 joules of energy which heats the room, and then the wasted energy is 8,000 joules. So as you guys can see, this Sankey diagram is definitely using the law of conservation of energy, because you guys can see that 12,000 plus 8,000 is 20,000, which means that it is going to be what you put in is always going to be the same in the outside. So now I'm just going to quickly tell you guys about how to draw a Sankey diagram. So the general rule is that the useful energies arrow is presented upwards or straight, and the dissipated energy arrow usually goes down. So this is not always going to be the case, but generally what happens is that, for example, in this diagram, you see that the useful energies arrow goes straight because that's useful, or sometimes it goes up. It really depends on the diagram. And the wasted energy usually goes down because obviously it's wasted. So that's basically a general rule for drawing a Sankey diagram. So if you ever want to draw a Sankey diagram, the best thing to do is to present the useful energy as a straight arrow, or an arrow that goes straight, and the dissipated energy usually goes down. And sometimes you could also get a question with joules or percentages. So for example, again in this diagram we can see that it's being presented in joules because we're showing how much joules went inside and how much joules are coming out. But sometimes it can also tell you the percentage. So for example, over here can be 100% and over here can be 70% that is useful and 30% that is wasted. So sometimes it can come as a percentage. So you have to really practice a lot of questions, and you should be able to know how to actually present it through percentages and with the amounts of joules. So now I'm just going to quickly show you guys an example of how to do this over here. So I have a question over here which says a light bulb contains 100 joules of electrical energy. It releases 10 joules of useful light energy and 90 joules of wasted heat energy. Present this in a Sankey diagram. So as you guys can see, I've already showed you guys the answer because I just want you to really understand. So again, what we're doing is we have 100 joules of electrical energy, and that's basically what you're putting in. So that's basically 100%, and then it releases 10 joules of useful light energy. So usually what you have to do is, in this diagram, they would usually put it in graph paper because you will have to draw a Sankey diagram in graph paper. And for example, even though this Sankey diagram is not presented in a graph paper, we just have to understand that each square would actually equals to 10 joules per second, or just 10 joules in general, because if we do 10 joules times 10 squares, it would be 100 joules. So if we was actually drawing this in a graph paper, this 10 joules would actually just be one square, and the 90 joules would be 9 squares, because that shows how much heat energy was wasted in comparison to the light energy. So this will be presented in a graph paper, but since over here it's not presented in a graph paper, you have to really understand the measurements about how you are going to draw it. So definitely try to do some examples in graph paper because it'll really help you to understand the measurements. So there you guys have it. This was my power and Sankey diagrams lesson. Just to go as an overview about what we learned today, we have learned about the formula of calculating power, which is power is equals to energy divided by time, and we also learned how to calculate and solve questions involving power. So again, all you have to do is that sometimes if they ask you to instead find the energy and you have the power and time, you just have to use a triangle and cover up what you're trying to find, and then you basically have to just go on from there and you can just do your working out. We also learned what is a Sankey diagram. It is actually a graphical representation of showing how efficient an object is. And last of all, we also learned how to solve questions with Sankey diagrams, which is obviously something you'll have to practice a lot on graph paper. So there you guys have it. This was basically my lesson. Definitely thumbs up this video and subscribe down below for more free science and maths lessons from the school station, and I hope to see you guys very soon in my next video. Bye guys!